talk about machine learning and how an AI brains look like and pretty much how they work in general. So imagine this is your brain. Well, no, this is the AI's brain. So how an AI brain works is it does actually look like this. We're gonna talk a little more about how it looks like, and imagine this is data or this information. So how a machine works is so you build the brain and there's nothing in there. So imagine you're just like a newborn child. You have a brain but you don't know anything. You haven't had any experience yet. This is pretty much how this is the state it's at now. It's called a zero. It's at state zero. It knows nothing. So the only way you can learn anything or become better is if you give it access to a lot of information or data. And data usually comes in the form of tensors. So pretty much you have to first build the brain, which is going to be called a neural network. And then feed it information in the form of tensors. And if you can do these things, you would have eventually created, you would eventually be able to create an AI. So let's start with the AI's brain. How do you build that? So pretty much a neural network consists of neurons which have biases and outputs. So let's say we have a not very complex brain or neural network with just let's say with just three layers. We have the input layer, we have the output layer, and then we have the hidden layer. These are our three layers. So these layers kind of interact with each other to create an output. And the output could be a prediction, like for example, let's say you're trying to build a neural network that's going to take an image and predict if that image is an image of a cat, a dog, or some other animal. So pretty much this is how it's going to work. So these neurons, you know, so each of these is a neuron combined together, and how they overlap forms the neural network. So the input layer is where the tensor comes in. Remember we talked about a tensor. We're going to talk more about a tensor in a second. Just like a tensor feeds into the input layer feeds into the hidden layer, and the hidden layer feeds into the output layer, and then you get your prediction. So let's talk about how specifically they connect together. For instance, each of this neuron has an output. Let's say this is one, this is two, this is three. And each neuron in the next layer has a bias attached to it. So let's say just three. Let's say the bias of this neuron specifically is 6, and the bias for this one is 7. Mind you, they're not going to be nice numbers like 1, 2, 3, 4, 5, 6, 7. You're probably going to get something like 0.004 or something like that. And no more than some crazy decimal number. So pretty much how this works is, say, for the hidden layer to get an output to pass into the output layer, it has to do some math. So it'll have to take in neuron 1, neuron 2, and neuron 3. All of their values multiplied by its bias and then form a new output to feed here. So for example, the output for this neuron right here would be 1 times 6 plus 2 times 6 plus 3 times 6. So once you do the math with all of this, let's do that. 6, 12, 18, what? 30, 36. So, so the output for this layer is going to be 36. So that same math happens here as well. 1 times 7 plus 1, 2 times 7 plus 3 times 7. And then whatever comes out here is the output for this one as well. So now this neuron gets its output and it feeds it into the output layer. The output layer will also have its own bias, whatever arbitrary number it is. You do the same calculation. So this one outputs 36, this one the output is, let's say 42, whatever it is, and then it feeds into here, same calculation, and then boom, you get some number prediction, and then if it's maybe less than 50, it's a cat. If it's more than 50, it's a dog, something of that nature. That's how you get your predictions most of the time. So the reason for the biases, it's pretty much imagine that's how your brain works. And for every information you get, you have a subconscious bias to it, maybe because of your experience and time on Earth. For neural network, the biases are very important. Let's say 0.07. Let's say this neural network has a bias of 0.07. And at the end of the output, it guesses dog, but the image is actually a cat. So what happens is your neural network tweaks itself. So it goes and it tweaks the bias of this, maybe moves it up one, then tweaks this a bit, and then if it finally gets, oh, cat, then it's like, okay, maybe this is not bad. Maybe we're getting close to something here. And it tries again, maybe with the same bias. And then, oh, if it gets dog the next time, it tweaks it again and change a couple of things. You just change the biases left and up and down, left to right until it gets to a point where it can accurately predict maybe 99% of the time if the image is a dog, cat, or whatever animal. So now that we've talked about a neural network, let's talk about tensors. So we talked about your AI is first alive. It's you build a brain, but there's no information in there. So it's pretty much it knows nothing. It's like a child. It only has two functions. It's only cry and maybe be cute or whatever. But for it to learn, you have to feed it information. And computers only understand, well, for the most part, computers only understand ones and zeros. And the most effective way to, I guess, train a neural network so far has been with tensors. Tensors are the simplest form of a tensor would be something like an array of numbers one, two, three, four. But since computers only understand the ones and zeros, it might just be one, zero, one. No, let's make that look better. One, zero, one, zero. But these represent something specific. So a tensor that you would use for an image would most likely look more like this. Let's say one, zero, one, and add one more tensor in here. Zero, 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 one. And one continuous tensor. So this tensor is what? Three? It's not 3 by 3. Okay, this tensor has three different arrays in it. So they could represent different things. Like for instance, this could represent the color at a certain pixel, and this represent the color at the next pixel, and so on and so forth until you have the entire image. So if you feed this tensor into the neural network that has been created to understand this tensor, you can eventually get it to give you output based on what tensor you send into it. So you would probably have to find a large database of images of cats, uh, images of cats, some whiskers in there, and then convert all of these to its tensor representation, which would just be something like this, and then like tensors, then zero, zero, another one. And just imagine all of these represent this image. And then if you pass this into your neural network, you get some output, which might be right or wrong, depending on whatever you put in there. And then you can, your neural network just tweaks itself over time until eventually it's able to predict a value with some level of accuracy. It's pretty much that's how a neural network works. Let's use different visualization to make it so we can better understand. Let's see something here. Awesome. So this is pretty much what I was drawing earlier. Um, neural a neural network. This is the input layer, this is the hidden layer, this is the output layer. The output layer sends out the prediction or the number that you're trying to predict. And then here you have your tensor. The tensor is what you pass into your neural network. So there's a vector, like the smallest form of a tensor, and then you have a matrix, and then you have tensor itself. Mind you, I said an array before. A vector and an array are the same thing. So pretty much when you convert that image of a cat that we're talking about, bunch of whispers in here, smiling cat's legs, tail. When you convert the image into a tensor, it pretty much looks like this. To you and me, it looks like nothing. It doesn't have any representation to us. But to a computer that is very good at recognizing patterns, this with enough training would eventually kind of look like this to it. Maybe not like this. It would just in its head, when it sees this, it thinks this. And to better understand what we've talked about, you have websites like this playground.tensorflow.org. So pretty much how these websites work, this website specifically is you can create your own neural network. So neural networks don't only have to be 3 by 3 by 3. You can have a neural network with a lot of hidden layers, varying sizes, and then you can play with it, and then maybe the output's only one, and then if you run this, where is it? If you run this, depending on how you structure this, you can get a prediction. So pretty much what this is trying to do is, depending on what neural network you create, it's trying to create a color pattern all for the blue that would contain all the blue, and another pattern that would contain all the oranges. So if you tweak this up and down, left and right, you can get it to be faster, slower, more accurate, less accurate. You can play with it to kind of figure out a good level where it would work the best. And all of these are kind of like parts or different things you would have in your neural network. We talked about the basic level, just the inputs. But you're going to have things like learning rate. This is how fast it learns. If you put it as high as possible, then that means each input value has a lot of weight. You put it as low as possible, then it has much less weight. And your activation, regularization, what else you have? You just play around with that, you kind of catch some understanding. And this is teachable machine. Google kind of created this almost application. So you can kind of play around with it and learn how the neural network can be created with images. So it will not let me use it because I'm using my webcam for Zoom right now. But if you click on webcam and then it will show you a screen, you take pictures of, let's say, your hand in an fully open position, and then take your arm in a fully closed position, and then take your arm, picture of your arm in like a scissors position, like rock, paper, scissors, and then you click on train model. It'll take a second, maybe 5 minutes, and afterwards, something's gonna appear on this side where you can show it different hand movements, and then it will try to predict whether you showed it a rock, paper, or scissors. Also, you're gonna have to name them, so you can use that name to label it. So this a bit, you kind of gives you a feel of how a neural network is created or is trained. So that's it for the video. Thank you for watching. Have a great day.